So today we're going to do a trigonometric functions review. Yay! Isn't trigonometry exciting? It's like one of the coolest things. Anyway, so first we will talk about degrees and radians. All right. So to talk about degrees and radians, the degree is what we normally use, right? And a host going an angle, a right angle triangle is 90 degrees. Going all the way around is 360 degrees. There is also the radian definition, which is defined or agreed on that pi is equal to 180 degrees. That is just simply something you need to remember. And so then half a right angle is pi of, so 90 degrees is pi over 2, and so on. And then the whole circle, which is 2 pi is equal to 360, which is a whole circle. And that should be enough. The radian, which is related to pi, is defined as the arc length divided by the circumference. That is, when you have an angle that's measured by a circle. Okay, here's your circle, and you measure an angle on it. The angle is defined as this distance, which is s, divided by this distance, the radius, which is r. So the theta, angles are often called theta, which is a Greek letter. That's tradition. Okay, we as mathematicians, you need to know a lot of Greek letters because that's the tradition, not because they're better than English. But we use theta. Now theta is like an egg with a line in the middle, and it equals to the arc length. That is how long it is, divided by the radius. And it doesn't really matter how big a circle it is, because the ratio will stay the same. You can have a big circle, it will just divide by a big radius, so that the angle measures the same no matter how the ratio goes, how the arc length or the radius is. So that's the definition of radians. Radians are better the same way that we use radian, because the same way that the whole world uses the metric system. It's just a way of measurement, but it's better, it's more convenient. And yeah, unless you're the United States, the only backward country who doesn't know enough to go to the metric system, right? Where I live. So let's move along. So the radians, you have to remember various things. Pi over 2 is 90 degrees, being that pi is 180. Therefore, 30 degrees is pi over 6. I'm now looking at, I should mention that I'm in section 1.3, Trigonometric Functions, and I'm on page 63. And we'll look at the example 1.22, which says, for example, you might want to convert 225 degrees into radians, or some of the pi into degrees, which, knowing this, then it is a direct ratio proportion, which we will not go over that much. So let's move along, okay, and get to the sine and cosine, which are far more interesting. Sine is the definition of sine and cosine is the sine is, you first draw your triangle. Okay, here's some triangle that I just made up, a right angle triangle, and here's your theta, and then this is called adjacent of theta. That means adjacent is an English word, means next to, right? This is the hypotenuse, and this is called the opposite side for obvious reasons. Now the sine, so then now we need to remember all the definitions of the trigonometric functions. First, sine is equal to, sine means opposite divided by adjacent, okay? Cosine is, and there's nothing to this except that you have to memorize it. Okay, there's nothing else to say about the definition. Cosine is adjacent over hypotenuse. what did I say here? Wrong. I mean hypotenuse. Okay, sine is opposite over hypotenuse. HYP. Cosine is adjacent over hypotenuse. And then tangent is opposite over adjacent. Now this is very important for you to memorize. If you've forgotten about it, you hurry and memorize that now. And then this is not so now that you memorize this, there are three other things. There are three other things that you have to remember. Well, no, you don't have to remember those. It's just something that people talk about for no reason. We don't need those things anymore, but you should know about them. You don't have to memorize them. There's something called cotangent, which is 1 over tangent. Okay, is cotangent. All these 1 overs. Okay, and then there is something called cosecant, which is 1 over cosine. Sorry, secant is 1 over cosine. They are not used very much, so it's just something, a matter of pride that you know it. They don't do that much good. And then cosecant is 1 over sine. Now notice that this thing forms a U shape, right? Here's my U. This is my personal U, a giant U there. Now whenever you can't remember what was cosecant again, you write down sine, cosine, tangent, cotangent. Cotangent, secant, cosecant. And then the one that lines up is the opposite. And that's how I remembered it in school. Is if I can't remember, what was cosecant again? Cosecant is 1 over sine. And what was secant again? Secant is 1 over cosine. Cotangent is just 1 over tangent. That's easy. That's the easy one to remember. So you write down stuff in a U shape quickly, in fact, in your mind even, and then you can remember what was cosecant again. But that's because this is not used that much. So another definition, as the book write down, is on the unit circle, where sine is the y distance, cosine is the x, and then tangent is y over x, and so on. That's another way of defining it. Is not better or worse. But you can see that, and that's good enough. All right. And then another thing we should mention is that sine, cosine, tangent are also defined on a circle of radius r, right? In that case, where you have a coordinate, the coordinate system of cosine in terms of the coordinate system of a point. Let's say you have a point on the Cartesian plane, which is xy. It always is xy. And then you want to represent it into some kind of a radius. Okay, what happens is that you draw a circle. There's a circle, and you have some point called xy on the circle, and you want to express it in terms of its distance from the origin and its angle from the origin. So the distance to the origin is called r, whereas the angle is called theta. And at that point, then you have to so then there's a different way of expressing x and y, where x is called our cosine theta, because that's the mathematical definition of cosine. Cosine is the adjacent over hypotenuse, whereas y equals to our sine theta. And that's another way of expressing the point. So again, that's just something you need to remember. We're not going to go over the proof or show how that's done. At this point, all you need to do is just remember that, because that's from trigonometry. And then there are certain values of sine and cosine that you need, and tangent, that you should memorize it like it's your best friend. The reason is because it's used a lot in tests. Okay, so you memorize these angles for the purpose of tests, and this has, and to recall, the you have two triangles that you have to memorize. The 30, 60, 90 degree triangle. This is 60 degrees, okay, or also called pi over 3. And then this is 30 degrees, and or this is 30 degrees, and that's the right angle. In that case, what happens is that you have the 30, 60, 90 degree triangle has that interesting quality that it has one, the shorter side, and two on the hypotenuse. And then the third side you memorize from Pythagoras theorem. 2 squared minus 1 squared, take the square root, is square root of 3. And once you memorize that, then you, from this triangle, you can figure out things like sine of 60 or sine of pi over 3 is equal to opposite divided by hypotenuse is square root of 3 over 2. And then cosine of say pi over 3 or 60 degrees is 1 over 2. And so on. All the related, and then tangent is tangent of 60 degrees is square root of 3 over 1. So anytime you can't remember what was sine of pi over 3, you draw your little triangle real quick that has the pi over 3 in it, and then figure it out quickly in your head, in fact. So similarly, there's another triangle that's very important for tests, for calculus tests, and is the 45, where the 45 degree triangle, right? 45 degrees is pi over 4, where the sides are both the same at 1, so the hypotenuse by the Pythagoras theorem is square root of 2. And then similarly, you can come up with the sine and cosine of these values very quickly, which is the sine of the angle pi over 4 is equal to 1 over square root of 2. And that's also called the square root of 2 over 2 when you normalize the denominator or something like that. But for now, we'll just remember it this way. It's something that you will be doing many, many, many times. So this is a good way to remember it clearly, if you have to remember it, right? So so having said that, let's move along to the next part. Oh, and I should mention that in terms of angles can be is measured various ways. So, for example, you can have something called how would you, out of this, let's calculate cosine of negative number. What is the cosine of a negative angle? Cosine of negative 5 pi over 6. Okay, this is example 1.23. All right, now the negative angle is just by why is an angle negative? It's only negative by definition. So it goes this way. Okay, mine is negative 5 pi over 6, so slightly less than the whole pi. And how much is it less by? It's less by 1/6 of a pi. And a sixth of pi is 30 degrees, being a pi is 180. So you have a 30-degree angle right here. And this is negative 5 pi over 6. Okay, so that's your whole theta. It goes from here all the way back here. Okay, now the thing is, then how do you calculate the cosine of this negative thing? You do it always, is you calculate the x. Cosine is defined as adjacent over hypotenuse. So the adjacent is this distance. You drop a perpendicular line here. Okay, so this is adjacent, and and this is the hypotenuse. So this adjacent value is going to be negative because x is on this side of x is negative. So so the cosine of this thing is going to be negative. But the angle, you calculate this angle here. That is, this thing only goes this way. But when you calculate cosine, you consider whatever angle it makes with the x-axis. And why is that? It's tradition. Okay, just memorize that. So the tradition is calculated. So basically, you're calculating the cosine of 30 degrees, and then put a minus sign on it. So what is cosine of 30 degrees? We have our triangle here, which is so it's negative cosine of 30 degrees adjacent over hypotenuse, which is square root 3 over 2. And that should be right. Yep, it is right. See, it says, oops, it says right here. I don't know if you can see it. Cosine is minus cubic 3 over 2. And that is the, yeah, that should be good enough for this part. And let's move right along. And the other angles are found similarly. That is, if your angle is always counted whatever it makes with the x-axis. I mean, the angle can not just go this way, it can wind around like 50 times or something, finally land somewhere. And no matter where it lands, you're always calculating its angle it makes with the x-axis on this side or this side. If this side is positive, this side is negative, whether it's for sine or cosine. Yeah, and for tangent. The tangent, of course, is defined differently. Then you consider both. For tangent, you have to consider both the y, the opposite, and the adjacent, but the principle is the same. And so next, there is a wooden ramp being constructed. No, we're doing review, so let's skip the wooden ramp for now. That's not gonna help you review that much. All right, and moving right along to trigonometric identities, which is far more exciting. Let's see. 1.25, 1.26 is about it. All right. Getting hot. Tired.